Hi, and welcome to another video tutorial in which I'm going to be giving you an introduction into Big O notation. So what is Big O notation? Well, Big O notation is a method of expressing the time complexity of an algorithm, and that is how much time the algorithm takes to execute. And I've got some types of types of Big O classification that I'm going to run through now, and then I'm going to show you how we derive the time complexity of an algorithm. So our first classification of an algorithm is O1, and this is called constant time. And for constant time, what we've got is a time complexity describing an algorithm which takes the same amount of time to run regardless of how big the input data set is. Okay, so we can say that an algorithm that takes the same amount of time to run regardless of how big the input data is has a time complexity of O1. Now our next time complexity is linear time. So that's ON. And what we've got with linear time is a algorithm which takes an increasing amount of time in proportion with the size of the dataset to execute. So the time for which the algorithm takes to execute increases in proportion with how big the dataset is. Okay, so with linear time, an algorithm that has a time complexity of linear time, the execution time increases in proportion with the size of the input dataset. The next one we've got here, the next time complexity we've got is polynomial time. And with polynomial time, the time for which the algorithm takes to execute is proportional to the square of the size of the input dataset. Okay, so polynomial time it describes an algorithm where the execution time is proportional to the square of the size of the input dataset. And the next time complexity you need to know about is exponential time. What we've got with exponential time is the execution time will double with every additional item added to the input dataset. Okay, so that's exponential time. And we've also got logarithmic time. And logarithmic time is a time complexity which will grow very slowly as the size of the dataset increases. And it is important to note that the base of the logarithm doesn't actually make a difference when we're talking about the time complexity of an algorithm. And the last one we've got here is factorial time. And with factorial time, the execution time grows very quickly with increases in the size of the dataset, and it's faster than exponential time. Okay, so that's all the different time complexities that you need to know for A level. And you may have noticed that I've got this graph over to the right hand side of my screen. And this is just a visual representation of how the time for which an algorithm takes to finish executing increases with the number of inputs the size of the input dataset. So you can see that factorial time will increase the most quickly with an increasing size of dataset. Then we've got exponential time increasing the second most quickly. Then we've got polynomial time increasing the third most quickly. And then we've got linear time and logarithmic time increasing the least quickly. And I haven't put constant time on there for obvious reasons, because constant time is the time for which constant time takes a constant time algorithm takes to execute is just going to remain the same. Okay, so at the start of the video I talked about how we work out what the time complexity of an algorithm actually is, whether an algorithm is factorial time, exponential time, logarithmic time, and so on. So I'm going to work through two examples right now, and I'll be putting up actual exam questions on big O notation from A-level papers in due course. But these are just two examples, and hopefully they'll give you the general idea of what you need to do to work out what the time complexity of an algorithm is. Okay, so I've got this code written in Python here, and I'll just quickly talk you through what it's doing for those of you who won't be familiar with Python. What it's doing is I've got a list here, and that's just that's just defined as being called values there. And what I'm saying here with this for loop is for the number of items in the list, so it's iterating through the list. Basically, it's executing this for loop for the number of items in the list. And what we've got here is values x, which is the iterative variable here, values and it's multiplying together the number in my list at that specific place in the list. So for example, if I was on the first iteration, my value of x would be 0. So at the list index 0, so this one here, square the value of this list index here. And okay, if you're going to times 0 by 0, you're just going to get 0. But then we're just squaring all these numbers in this list. So that's what the code is doing. But how could I find the time complexity of that algorithm? Well, what we need to do is look at the number of operations it performs which are relevant to the size of the problem it solves. What I mean by that then is that we're looking at the operations such as a for loop or an if that are executed a number of times based on the size of the input data to our algorithm. So in this example, I've got a for loop which is executed a certain number of times, but that depends on how big my input list is. So we're looking at how many times this for loop is executed, and I can see that the for loop is executed the number of times. A certain number of times depending on how many items are in the list. So if there were n items in the list, my for loop would be executed n times. So this means that the time complexity of this algorithm here is going to be linear time, O(n). And the reason it's going to be linear time is because as I increase the number of items in my list, the for loop is going to have to the for loop is going to have to execute an increasing number of times, and the number of times that the for loop executes is increasing in proportion with the size of the data set. That's why I've got linear time as my time complexity here. Let's just go through one more example then. So I've got a simpler algorithm here, and I've got my same list here, values. And all this algorithm is doing is I've defined a list values, and then it sets this variable first item equal to the first item in the list. And the reason I'm showing you this piece of code is because this is an example of constant time. And the reason this is an example of constant time is that it doesn't matter how big my list is. It's always going to just do one operation, which is looking at the first item and storing that as first item. So we're not actually changing the amount of time that it takes to execute the algorithm with the amount of data that I'm inputting into my algorithm. And that's really what big O notation is about. It's seeing how it's seeing what effect changing the amount of input data has on the execution time of the algorithm. Okay, so that brings me to the end of this tutorial video on big O notation. I will do some more examples of big O notation in the future and how to derive the time complexity of an algorithm, because I know that's something that is sometimes difficult to do. But the examples that you'll have to do in the A-level exams should be relatively simple examples of big O notation. Okay, so I hope you found that introduction to big O notation useful. Thanks for watching.